Hey guys, welcome back to the channel and this new tutorial on advanced Python. So in the last couple of videos, we learned about magic function and variable length arguments. And in this video, we will learn about super method in case when we are doing multiple inheritance. Okay, so we know that how we can initialize super classes using class names, but they are not always optimal way of doing it. So they can be really messy when we have multiple or many classes to be initialized, as well as when we change a particular class. So in class based initialization, we need to change it in a subclass initialization as well. For example, in this case, if I will add another class C, I will need to add another initialization for C as well. You see, that's a kind of a bit um, not really Pythonic way of doing it. And also, if I change something here, let us say I added something like B1, I need to change the initialization part as well. So this is where this super method based initialization comes handy. You do it just once and then you don't need to change anything later on. So that's where this is really useful way of uh, doing initialization. Okay, so we will learn that part in this video. Okay, so let us dive in and start uh, like how we can use super method to initialize super classes without using class names. Okay, so let us see how we can how we do it. So first of all, we will use this variable length argument approach to make it like we can pass as many arguments as we want, and then we will use a super method to pass on those arguments to the super class. Okay, so let us do that. So we can simply use star args and star k word argument. Okay, and then we can simply use a super method and simply pass these to the super class. Okay, let us see what we receive in class A and B. So let us uh, use A and B instead of BA. Okay, so now first it will go to class A and then it will go to class B. Okay, that's what we have defined. We will see in the next video like how it resolves it, like which particular class constructor calls first and what order it will call. So it uses this L3 linearization technique to decide it, but we will see like how that works in the next video. Okay, so in this case, let us see like what we receive here as inputs. Okay, so here you need to add star args and star keyword arguments as well. So now let us see what we receive here as these values. So let us print them. So let us say print args and let us print keyword argument. Okay, so let us run and see what we get. Okay, so okay, so it says like extended object has no attribute b. So what is happening here? So the problem is here like so we called super method here that will call a, then we didn't call super on this again because it is like a sequential initialization. So it first call a super for a and then a should call super for b as well, then only it will get initialized. Okay, so that's what we need to do. So we can simply say super and then we can simply pass here. Okay, now let us run and see it. So now you see it is able to properly initialize them. Okay, so now let us print here args and keyword argument. So now we'll see like how these arguments are being consumed. Okay, so let us run and see it. So you see, so our args is not there because we are using keywords to pass the arguments. That's why we have only a keyword. But important thing to note here is like it has consumed a here. Okay, and the remaining keywords are here. That's what is passed to initialize b. So you see, now if we will change the order, like if I will say b and a, now it will fail again. You know why? Now I think you know, because here it is not updated for that particular purpose. So what we need to do is, let us run and see it. It will fail definitely, but so you see it says like init got an unexpected keyword a. Okay, so let us change it for that as well. So we need to is add star args and star keyword argument, and we need to do the same thing here as well. We need to call super and then simply pass positional argument as well as keyword arguments. Okay, now it will work for this as well. Okay, so let us run and see it. So you see, so here it has consumed b and here it has consumed a. That's why we don't get anything here. So let us print this in class b as well. So you will see like here you will get only a remaining because b is consumed already. Okay, so let us run and see it. So you see a is remaining. Another important thing to note here is like order matters here. If you don't specify keyword based arguments, it will simply first it will consume the first argument and then second argument and so on. It won't see like, because then it will use this. Okay, and then simply it will use the first one to initialize b and the second one to initialize a. Okay, because we are calling b first and then a. Okay, it is simply like in what order the super method is trying to initialize the classes. Okay, that order, in that order the passed arguments will be consumed. Okay, simply if we are using these positional arguments. Okay, so let us see that. So it will first use 2 for b and then second it will use 3 for a. Okay, so let us run and see it. You see a is b, so first it is b, b is 2 and then a is 3. Now if we will change the order, that will change. So now first it will initialize a, which will be 2, and the next it will initialize b, which will be 3. Okay, so now let us run and see it. So that we can handle if we simply say, okay, I want a is equal to 2 and b is equal to 3. Now even if we change the order, okay, that will be the same because now we are using keyword arguments. Okay, so now let us check that. So now you see it is 2 3. Now if I will change the order of this to b and a, it will still be the same. Okay, you see still a is 2 and b is 3. Okay, now next thing, let us see like if there is another method. Let us say we have another class c. Okay, let us define another class c and let us simply say define init and let us say c star 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 args and star star keyword argument. Okay, now let us say simply self dot C is equal to C, and let us call super as well here, and let us simply pass these two further for initialization if there will be any. Okay, whereas we don't have any, so let us define another hello. So hello, and let us print. So let us copy it from the other methods so that it will be consistent. We can simply say self-c. Now what we will do is simply let us extend a from C, okay, and also let us extend b from C, okay. And now let us add another variable here. Let us say C is equal to 4, and let us now print extended dot C. So you see, it's like you don't need to modify anywhere else when we extended this new method. Okay, so this is why super method based initialization is really handy when we have these complex inheritance or class inheritance. Okay, so let us run and see it. So you see it says 2 3 4 and so on. Also you can add like C here as well, and then it will work simply. It won't complain anything like that. Okay, so I think that should be clear, like how we can use super method to initialize super classes. Also like how the arguments are being consumed in that sense. So if you have queries, ask in the comment section. I will try to explain again. Okay, so I think we will stop in this video here. And in the next video, we will learn about L3 linearization technique, that how it uses method resolution order to decide like which particular init method is called first and so on. Also like if we have common function names or common method names, which method it will call when we try to call. For example, if I will call here extended dot hello, which one it will call in that sense, that is decided using this method resolution order technique. So we will learn that in detail in the next video. So thanks for watching. Bye for now. Take care. See you in the next.